Hi, welcome back to the channel. So today I want to solve this question. The question says find the exact value of the integral from 0 to pi over 2 sine 2x over sine x plus 2 dx. So in order to solve this question, we need to use method of substitution. Let's say you can choose any variable that you want. So I'm gonna just choose a u is equals to sine x. All right. So wherever there is sine x, we place a u. Okay. So now we need to find dx. We need to convert dx and place it in the form u. We can derive u is equals to sine x in there. So let's say du over dx is equals to cos x. Dx is equals to, okay, so dx now is equals to du over cos x. All right. We also have sine 2x. You know the identity. Sine 2x is equals to, okay, like this. That's 2 sine x cos x, like this. We can also change the limits, and not we can, they need to be changed. It's a requirement. You cannot solve with because those are x values. We need to convert them into u. Okay, so we know that u is equals to sine x, right? U is equals to, this is for the upper limit. Let me just write a p, up to denote the upper limit. So that will be sine pi over 2, and this is equals to 1. So ul, lower limit, will be equals to sine 0. Sine 0 is just a 0. Now we have everything. We can go back to the integral and place our integral here. Integral of 0 up to 1 sine 2x. We can write 2, or where there is sine x here, I'm not going to write sine x, I'm just going to write a u multiplied by cos x. All right. So we can say all over u plus 2, right? And then dx is equals to du over cos x. All right. Yes. So we can cancel the cos x and the cos x. Then we're left with the 0 to 1 to u over u plus 2 du. But we cannot solve this. We need to divide the 2 to simplify so that we can integrate it. So we can factor out 2 and say the integral of 0 up to 1 u over u plus 2 du. All right. So u plus 2 into u, we can use long division. That will be, okay, can use long d. So this is u and then u plus 2 here. U into u, we get a 1. We get a 1. 1 multiplied by u, we get a u. 1 multiplied by 2, that's a plus 2 bracket and then minus here. U minus u is equals to 0. 0 minus 2, you get a minus 2. So minus 2 is like a remainder, right? Yes, it's like a remainder. So we're just gonna go back to the integral and then we write to the integral of 0 up to 1 u over u plus 2 is, we write the 1 is here, the 1 at the top, and then we say minus 2 all over u plus 2, then du. Okay, we can spread the 2 as integral of 0 up to 1, 2 minus 4 all over u plus 2 du. Okay, so let's integrate now. If you integrate 2, you get 2u. In this case, we get 2u minus 4 is just like a constant. We factor it out, and then ln of u plus 2. Because we have constants now, we must not write plus c, so you can just place the limits here and then compute. You don't need to go back to substitute sin x wherever there is u now, because we have limits. You can just work it out like this. So 2 into, let me separate the 2 into 1 minus 4 ln bracket 1 plus 2 bracket, and then a bracket to say minus, right? 2 into 0 minus 4 ln bracket 0 plus 2 bracket. We have this. So now 2 minus 4 ln 3, so ln 3, that will be a plus because 2 by 0, it's a 0. Minus and minus gives us a plus, so plus 4 ln 2. All right. So I can finally write 4 ln 2 minus 4 ln 3 plus 2. This can be simplified to 4 ln 2 over 3 plus 2. Or this can be, you can actually plug it into the calculator and see whatever you get here. It must be 0.3 something. Yeah, that's what you got. You get. Okay. So this is how you solve these types of questions, and please don't forget to like, comment, and subscribe. Bye bye.